Hi everyone, I'm Seth Benzell, postdoc at MIT with Eric and Dan. This is joint work with Guillermo Lagarda in the corner there, as well as Larry Kotlikoff and Jeff Sachs at the Earth Institute. So we've talked about a lot of reasons that people are anxious about artificial intelligence and automation. But we think that new technologies push out the production possibilities frontiers. So what should we be worried about? Well, here's a couple of things that have been talked about today. So, for example, Pasquale told us to worry about distributional challenges and inequality. Catherine Tucker told us to worry about, well, maybe there's going to be algorithmic bias and the AI is going to do things that either we don't like it to do or we don't understand what it's doing. We talked a little bit last night over dinner about, well, value alignment, and maybe these AIs will become super powerful and not do what we want because they're not going to care about what we want. So, but what I'm going to talk to you, and then you might also think about transitional unemployment, so skill mismatch issues like in Pasquale's job market paper. So what I'm going to do today is maybe lay out one more thing that you might want to worry about when it comes to automation. So let's consider a different type of fear. So think about a world where automation, or robots for short, are so productive that labor is superfluous. So if you have $1 of investment to make, you're not going to invest it in a labor complementing technology, you're going to invest it in a robot. But also a future where savings and investment are so scarce that per capita income is low, right? It turns out there's, from a Boston University professor, Isaac Asimov, there's actually a book about a world like this. It's called Caves of Steel. It's a world where there's a huge boost in human population. No one has any jobs because robots do all the work. But they've kind of got this socialist economy where everyone's on the dole. And the socialist economy does a really bad job at reinvesting into the future. So what we want to think about in this paper is a future like this possible in the long run without some sort of market or government failure. And our answer is yes. And so we're going to give you the intuition in a simplified model, because I only got 10 minutes. The way that this process works is that artificial intelligence and automation technologies shift factor incomes from labor to capital. We put this in overlapping generations framework. And in an overlapping generations framework, the source of savings and investment are young workers saving for their retirement. What that means is if you shift factor shares of income from labor to capital, you're going to have a much lower saving rate in the economy. And that means in some parameterizations of the model, you can lower long-term welfare through this process. So one way of thinking about what we're doing here is, you saw Pasquale's paper yesterday, you saw a couple other papers where we were interested in how the technology is going to change investment demand. What I want you to think about is how is technological change going to change investment supply? Okay, so here's the simplified model. Suppose output is Leontief in effective labor, A, and capital, K. Before AI exists, workers just work in the economy. They provide ZL. After AI exists, effective labor is going to start to accumulate. So effective labor is going to be ZL, but plus some of the effective labor that you did yesterday starts to get retained. So you can either think about this as workers find it more effective to sit down and do code rather than working directly, or you can think of this as a sort of supervised learning process, where as workers do more of their sorting task, the AI gets better at replicating what the workers are doing. So delta is going to reflect the rate at which yesterday's labor is retained as effective labor tomorrow. And we're going to be interested in what happens when delta increases from 0 to some positive number. Households are, again, it's an OLG model. Households are going to live 2 periods. When young, they work and they provide their L. And when they're old, they consume their savings plus whatever interest they accumulate. When they're young, they're going to make income based on the marginal product of their labor today, plus if some of their effective labor is getting preserved tomorrow, they get to sell the rights of that code. Households are going to save fee of their income, and they're going to hold their assets in the form of capital and code. So fee times the income of the young is equal to the capital stock tomorrow plus the value of the code base tomorrow. The marginal product of labor and the marginal product of capital are set by their relative abundances. So it's the price of code that's going to adjust so that the AI capital stock and the physical capital stock have the same rate of return. So what happens when we start to retain more code? Well, retain labor. Well, labor starts to accumulate, according to that accumulation rule. One period after labor starts to accumulate, output must increase, right? And the way to think about this is we had some capital sitting around that we weren't using. So as we have some more effective labor, we're able to take advantage of that and make a little bit more output. But now let's think about what happens as as effective labor continues to accumulate. So long as labor is relatively scarce, it's going to make 100% of the income, right? As labor is relatively scarce, Leontief production function. But eventually, we might get so much labor that now capital is comparatively scarce, and it's going to make all of the income, all right? This is Leontief, so this is super stark. In the full model, it's CES, so this process is much less stark. So what happens when that happens? So when the technological improvement delta, so our ability to retain effective labor is small, or the saving rate is large, we had a lot of extra physical capital sitting around, the economy is just going to move to a higher output steady state. So the condition for this technological change to be good for long-term welfare is that phi is sufficiently high and that delta is sufficiently small, and that the physical capital intensity of the production function is also sufficiently small. However, if we accumulate too much effective labor, workers are eventually going to become the abundant factor. They're going to make no income. Where does saving and investment in the economy come from? They come from workers saving and investing their income. So output will collapse in all subsequent periods if that happens. Now, one thing to think about is, is this some sort of violation of the fundamental welfare theorem? Shouldn't in the fundamental welfare theorem, if we have a technological improvement, you can't make everybody worse off? There has to be at least one guy who's better off. And the answer is there is one guy who's definitely better off. That very first generation benefits from the change. So this isn't some sort of market failure. It's a case of intergenerational redistribution from all future generations to that very first generation that benefits from the technological change. So what do we do in the full model? So in the full model, we have a lot of additional features that make what goes on a lot less stark. So there's two goods. There's an automatable sector and a non-automatable sector. The automatable sector takes effective labor, capital, and AI as inputs. The non-automatable sector takes what we call high-tech labor and low-tech labor as inputs. So the low-tech labor can't work in the automatable sector. There's those two types of labor. And one of the interesting things you can get as a result of this is that when the initial wave of AI technologies become possible, when delta first increases, it's going to be a big benefit for the high-tech workers. But in the long term, the situation can flip. And it's the low-tech workers who work in the sector that doesn't use the AI technology that benefit in the long run. We also have an extension where we think about property rights over these AI technologies. So what happens when AI is rival versus non-rival and excludable versus non-rival and non-excludable? So here's an example of the immiseration dynamics in the full model. So you can see there's a short initial boom in national income that eventually goes down by about 15%. Effective labor accumulates, capital stock decumulates. You see the wage, little boost in wage, and then it goes down in the long run. And you can see that in welfare too. There's a boom in welfare for the people retiring who were young when the technological change happens, and then the long run workers are worse off. There's a huge range of outcomes possible. Up to negative 15% when you've got a high code retention shock. But if you've got a lot of extra code and you had a lot of capital sitting around, then it's really good, 20% improvement in welfare. Other results, it turns out that in our extension, so banning AI ownership doesn't necessarily solve the problem. Government programs to boost savings or transfer income to the young can save the problem. But that's not what we're doing right now, right? Government's going big into debt to fund social transfer programs to old people, boomers. So is this happening? Future work? We definitely see a decrease in labor share. We definitely see an increase in the intangible asset share. We don't see an increase in interest rates. So the fact that we have really low real interest rates over the last 30 years is a real riddle, given that in models like Pascal's, the initial reaction to an increase in automation technology should be an increase in investment demand, and that should increase real interest rates. And maybe if you have a representative agent in the long run, that equilibrizes. So one answer is some work that I'm working on with Eric right now, which is thinking that maybe the limiting factor isn't our ability to invest in these robots, but some sort of ability to implement them. That would be a reason why real interest rates aren't so high. One more thing to worry about.